Good morning. So welcome to this session. So in this particular session, I will be continuing with projections of lines. If you just remember, in the previous session, we have started doing problems wherein the line was inclined to both HP as well as VP. And also told you that since already we have done a case wherein the line is inclined to one plane and parallel to other, since we have done that separately, then I was telling you that to do the problem wherein the line inclined to both the planes can be done in three stages. In stage 1, we will consider the line is inclined to one plane and parallel to other. So in that particular stage, we are going to get the locus as well as we are going to get the ends which are fixed, and also we know that the locus, and also we are going to find the length of the top view or the front view, that is in stage 1 and stage 2. In stage 4, we know that since the line is inclined to both HP as well as VP, the light will no longer be parallel to either planes, so that I am going to get the lens to be foreshortened lens both in the top view and front view. We consider them as LTV and LFV. So I know LTV, LFV, and also I know the ends in both top view, and that is the NA and the NB in both top view and front view. That is, I know the locus. Now since I know the locus in both front view and top view, and also I know LTV and LFV, I can find the final projections. And in the final projections, also we have seen that once we draw the projections, then we know that once those two LTV, LFV is arranged within their respective loci, then they will be in projection with each other. Okay, so let me consider one more important problem wherein I will consider a line. Let us say you know the true length. Let us say I know the true length. Let us say it is given as 80 mm, and this particular line inclination, let us say given as 45 degrees to HP and let us say 30 degrees to VP. But here what I will give you here is, let me consider that one end of the line in HP and the other end of the line is in the VP. Okay, so I am just considered that if I consider the line containing the ends A and B, I can say that end A is in HP and end B is in VP. But if you just remember, in the previous problems, I have given the same data. That is, I would have given the true length of the line, I would have given theta and phi. Only thing is, there I would have given one of the ends, that let us say I would have given end A is fixed, that is I would have given the position of the NDA to be, I can say that 20 mm above HP and 30 mm in front of VP. That is, I would have given the NDA position directly, I would have given completely. But in this particular case, it is given that NDA is in HP and NB is in VP. So with this as a basis, I need to do this particular problem. Okay, so let me do this problem together. Then I will also show that, or I will do one thing, I will just do this problem in three stages. Then let me do this problem in a single stage. Okay, now let us say if you want to do the stage 1. So stage 1 means what? I will consider line is inclined to one plane and parallel to the other. Let me consider that the stage 1. So let me draw here. I will consider the XY line as usual. Now let me now consider that line 80 mm length is inclined at 45 degrees to HP and parallel to VP. Okay, now since the line is parallel to VP, we know that true length of the line will be seen in front view. So I need to start from front view. Okay, now if we want to start the front view, I should know its position of this particular details what is given in the problem. It is given that end A is in HP. What do we mean by that? That is A dash will be on X1 in itself. I will get this point to be A dash. Then I know the TL. So TL is 80 mm and its corresponding inclination with reference to theta is 45. That I can draw it in the front view. So let me draw that. So let me show that. So line is inclined at 45 degrees. Then I know the true length. So let me consider this to be TL. Then this angle is theta. And what about this end now? So I will call this as B1. Remember, this is not the final projection. Since it is not the final projection, I will call by this subscript. Let me consider this as B1. So this is the front view. Now I should draw the corresponding top view. So what about the corresponding top view? Now as you can see, the line is in HP, but I don't know with reference to VP. Okay, but still the projected length will be your length of the top view. So what I do then, that is I will simply draw a projector through this. Then I will call this as, let us say, V1. Then what is this length then? This length should be equal to length of the top view. So I will call this as LTV. See, you would have done this below XY line. What we have done in the previous, but anyway here I don't know any details in the top view. Since I don't know any details in the top view, I will consider on XY line itself. Okay, so this stage 1. So what about stage 2? But anyway, you know that in stage 1, we are able to determine LTV as well as I am able to determine the locus. So let me consider this particular line. So I will consider this line to be what? I will consider this line to be locus of B dash. Okay, and already in the XY line what we have? Here already we have locus of A dash. Okay, now this is stage 1. Now we need to stage 2. So what about stage 2? In stage 2, I will consider the line is inclined to VP and parallel to HP. Now since the line is parallel to HP, we expect that the true length will be seen in top view. I will start from top view. Okay, how do we start the top view? Anyway, you know that one end is in HP and the other end is in VP. So what do we mean other end is in VP? That is B. So B should be on XY line. So I will consider this point to be B. Now since B is on XY line, B is in HP, what do we expect that other end? The other end, which is the other end then? Anyway, end B is in VP. Now since the end B is in VP, the other end, which is your end A, has to be in front of VP or it should be below XY line. But anyway, I know the TL. So TL is given as 80 mm. Then the angle with reference to phi is given as 30 degrees. That I am going to draw in the top view. So let me consider this. Okay, I think this is okay. So now what is this point now? This is B, this has to be A. But anyway, can I write simply A here or do you want me to write something subscript here? I need to survive it because this is still, it is not the final projection, it is actually the true length line. So I will consider this as TL. I will call it as A2 because already I have taken B1 now. So I will just consider it as A2. Then what you do then? Now anyway, this is your B and I need to find its corresponding length of the front view. So how do you find the length of the front view? I need to draw the projector. So let me draw the projector. So anyway, A dash is on XY line because I am not going to extend. Why I should not extend? Because it is a locus of B dash. So already A dash is on XY line itself now. So that is the reason I am going to restrict only up to the XY line itself. So this will be your, this is A2, this becomes A2 dash. Then what is this projected length? Projected length, because anyway the line is inclined to VP now. Now since the line is inclined to VP, in the front view it should be foreshortened length, and that foreshortened length we call it as LFV. Okay, and what else we have found out here? Okay, now anyway we have A2 here. Now since it is A2, if I draw a locus line, what is this line corresponds to then? This particular line or locus corresponding to locus of A. Okay, and also I said that B is in VP. Since B is in VP, what about your locus of B? Locus of B also should be on XY line. Locus of B. Now as I was telling you, from stage 1, stage 2, we are able to determine LTV, LFV. Not only that, we are able to determine the ends A and B in the top view as well as in the front view. Now anyway, I know all the what are 6 parameters I know now? I know all these loci and also I know LTV and LFV. Now what is the next step? the next step is I need to arrange. I need to arrange what? I need to arrange LFV in the front view and LTV in the top view such that they should be in projection with each other. Okay. So let us say we will start from front view. Okay, anyway front view, I know that this is the point A dash. Is it okay? Now I know LFV. So what I should do then? I will take this length and this as center, I should draw an arc. Okay, let us say this is the point I am going to get. So that what is this point then? This is A dash. What about this then? This is B dash. So if I join this is the final projection in the front view. Okay, what about the corresponding top view? We know that A dash, same projector, B dash, same projector. Anyway, A dash is here. So A is here. Then what I should do then? I should draw the projector. So if I draw the projector, then I am going to get this top view of that particular end, that is A. Then B dash is here. So I need to again draw the projector. Now we know that B dash should be on the same projector. But anyway, B is on XY line. So I will draw the line like this. I will draw this projector. Then this point will be what then? B dash, this should be B. Okay, if I join this, AB will be the final top view. As you can see now, A dash, B dash are the same projector. Not only that, if you have done the problem right, so what is the check I can do? Anyway, this should correspond to what then? Anyway, I said this is corresponds to LFV. What is this should be corresponding to then? This should corresponding to LTV. Where is your LTV? It is in the first figure. Now, if you have done the problem right, this length should be equal to this length. Similarly, this length should be equal to this length. Not only that, if I measure these angles, so what about this angle now? Now again see this. This is the ends, that is locus of B dash, locus of A dash. This is TL. So TL is actually the true length, which is make an angle of theta. Now what is this? LFV. And we are going to put this line with the same locus length only. Since with the same locus line, this length is more, this length is less. What about this angle then? This angle has to be greater than theta. That is the reason we call this as alpha. That is the apparent angle because the apparent length. So your alpha should be greater than theta. Similarly, if you measure this angle is beta, which should be greater than phi. So as you can see, I had just done this problem in 3 stages. Let us say I am very confident. If I am confident, I can do all these 2 stages in a single figure. So that I am going to illustrate now. Okay. So let me draw this XY line. Anyway, stage 1 is, I will just do it. So stage 1 I will do it. Because anyway, A dash. Then I will get this angle to be equal to 45 degrees. I will call this as B1 dash, TL, then this angle is theta. Then if I am going to draw this line, so this should be what then? Locus of B dash. Anyway, A dash I have taken here, so that this should be locus of A dash. Then if I draw the projector like this is B1 dash, this will be B1 and this is empty. Same thing what I have done in stage 1. Now stage 2, here I have done separately. Now let me do here itself. Now we should be careful. Okay, now what is stage 2 I need to do now? It is given that in stage 2, the line is inclined to VP but it is parallel to HP. Since the line is parallel to HP, I need to start from top view. How do you start the top view? Because anyway, I don't know still locus of B because it is given that one end of the line is in HP, that is I have taken A dash, the other end is B, so B is in VP. Now since B is in VP, we know that, what about the locus of B then? Locus of B should be on XY line. Now anyway, where is B? Because this is A dash. So I have some point here which is given as B1. I got it intentional accidentally because B1 dash here I got this B1. Now you had an idea. How I start with drawing the top view, which is your reference point. See, I will not take here because reference point already is A1 dash now. So A dash, I will not talk. Anyway, we have some reference point for B here. So what I do is, here I will draw this projection. So now what I do then, with B as a point, I will draw a line which is inclined at 30 degrees to VP, and so that I am going to get locus of A below XY line. Is it as simple as that? Okay, so let me do that. Okay, now this angle is phi, and again I am going to the same length now. So let me take the same length. I think it is okay. It's almost here. So this is B1. This should be A. We call it anything. Let us say we call it as A1 only. You call, because anyway I don't have A1 there now. So I call it as A1 only. Not an issue. Okay. Now what is this? This is TL, and this angle is theta. Okay. Now its projected length will be your LFV. That is indifferent to you. So then what you do then? Same thing. What I have done here, I am going to just repeat it here. So then what I do then? I will draw a projector through this. So that this will be A1. I will call it as A1 dash. Then what is this length equal to then? I will consider this line now. So this length, let me show it separately here so that you will not get confused. So this length should be equal to LFV. Now since it is LFV, don't write it below XY line. Better now, we will draw it above XY line. So let me do that. So I will not show it here. I will show it there. LFV. Now already we have the locus of A dash, locus of B. What about locus of A? It should be below XY line. So we just draw a line like this. So that this will be one locus of A. Now I know locus of AB I know, locus of A dash B dash I know. And also now I know LTV LFV. Then what I should do then? The final step I need to do is your LFV LTV should be arranged such that it should be between A dash B dash and between A and B. Let us say we start from front view. So let us say already we have A dash now. Let me consider this point itself is my A dash. I will say A dash. Okay. Now from A dash I should take this between these two locus. Which way I have to fit? I have to fit LFV. Where is LFV? This is my LFV. So I will take this LFV. With this as center, I am going to draw an arc. Is it okay? So that if I join this is your final B dash and A dash. And now I need to draw the corresponding top view. So what about the top view? A dash A, same projector. Anyway, A dash is here. A should, locus of A is here. So you draw the projector up to that. So I draw this projector. So this is A. Then this is B dash. Where is B? B is on XY line. So I will draw the projector through this. I will get this point to be B then. Then what I do then? I am just going to join this A to B. So now this is AB is the final top view and A dash B dash is your final front view. And again just see this angle now. So now we can clearly make out this is theta, this should be alpha which is greater than theta. Similarly here we have this angle. I said this angle is what angle I said? This is phi. Anyway complementary angles now. Okay. Now what about this angle then? This angle is beta which is greater than phi. So as you can see, generally students will get confused. Especially after doing the first stage, you will have a dilemma. How to write the top view in the second stage. But since I told you that already we have a reference point here, I written like this. You can ask, why can't you write like this? You can draw like that also. See, finally what I wanted to get the final projection, finally what I want is, I want this locus and also I want this LTV LFV. So even if you do in this way also, I am doing same LFV only now. But anyway, then I am going to get the final top and front. Okay. Okay, so let me do one more problem. Where the data given is, let us say below the true length. Let us say true length is given as 75 mm, and let us say I have given theta as 30 degrees and given phi, that is inclination reference to HP is 30 and inclination reference to VP is 60 degrees, and again consider that let us say end P is in HP and end Q is in VP. So now we can see this problem is exactly similar to what we have done in the previous class, especially if I consider these ends. There I given end A and end B. I would have given simply as end P and end Q. But you can just notice there is one difference here. What is that? Again TL 75, theta is given, phi is given. But if you just observe the combination of theta and phi, what I have given in the problems, what already we have done, I have given always less than 90. Why it should be less than 90 or at the most it may be equal to 90? Because anyway we know that inclination of theta with respect to HP, inclination of VP is given as 60 degrees, and also we know that those two planes, we have two planes HP and VP, how they have been displaced? They have been displaced by 90, see it cannot be more than 90. So remember, whenever we give any problem, the sum of the inclinations theta and phi has to be less than 90. If you have observed what are the problems you have done. But the special case is wherein the sum of the inclinations are given as 90 degrees. Now let us say the sum of the inclinations as 90 degrees. Let us say it is like this. Okay, I have just given like this. Now I have given that end P, let us say I have considered this pen. Okay, this is end P. Let us say this is end Q. So P is in HP and Q is in VP. But I have given some of the inclinations as what? 30 and 60. So if you just see here, if I just hold it in this way, you can just observe. If I just hold it in this fashion, if this angle is, let us say some theta, the other angle has to be 90 minus that angle or 90 minus theta, because anyway these two are inclined at, displaced 90 degrees. So whenever I give this sum of the inclinations as 90 degrees, then if I just hold it like this and if I just put it here, so anyway I know that this is HP, this is VP, and as I was telling you, if I stand from the front, this is VP, HP. Okay. Now let us say if I look from the side, that is, if I look from this particular, either from this side or that side, since the line is like this, I can say if this line, let us say, projected into this third plane. So which is the third plane? Already we have seen. The third plane is the profile plane. If I simply do like this particular line will contain there. How do we contain there? That means say that this particular line, since the sum of the inclinations are 90 degrees, the true length of the line will be seen in a third plane. What is the third plane? This third plane is perpendicular to both HP as well as VP. We call that as what plane then? We call that as a profile plane. So remember, whenever I give sum of the inclinations as 90 degrees, then the line is contained in PP or profile plane. Since the line contained in profile plane, the best way is I can also start from side view itself, because anyway line contained there. Now once I say line contained means I can see true length and true inclinations with reference to HV, VP both in the side view itself. So I can start from side view. Okay, but anyway let me first do this problem with our regular procedure. Okay, now anyway since the line is like this, if I look from the front, how this line looks? If I look from the front, this is like this now. So once I look from the front, since the sum of the inclinations are 90 degrees, this particular end will be, seems to be in XY line itself, and this end will be here, that is in the VP, so that if I see from the front, the final projection will be perpendicular to XY line. Similarly, if I look from the top, you can see this particular point will coincide here. This point will come here, so that if I look from the top, so this particular line will be perpendicular to XY line. That would say that if I say the sum of the inclinations are 90 degrees, then the final projections has to be perpendicular to XY line. But of course, there will be foreshortened lengths, and those lengths will be LFV and LTV. Okay, so as I said, let me first do this by the regular way, then I will do this problem considering from the profile view. Is it okay? Yeah. Okay, let me do this problem. So first I will draw this XY line as usual. Okay, now Since I said that true length is 75 mm and inclination with reference to HP is 30 degrees, I will consider line to be parallel to VP. Since the line is parallel to VP, I can show the true length in the front view. Start from front as usual. Now anyway, NP is in HP, so I will consider the NP here itself. So consider this as P dash. Okay, now I know the true length. So true length is given as 75 mm. So let me draw that, and inclination is 30 degrees. So let me draw that. Okay, so since this is TL, I told you that this has to be called by not final Q dash, by a subscript. Let me call it as Q1 dash. This is TL and this angle is theta, and if I draw this will be the locus of Q dash, and this is locus of P dash. Then as usual projected length. So what is the projected length now? So this is Q1 dash, let me call it as Q1, so that this particular length should be equal to your LTV. See, same thing what I have done earlier, I am doing the same. The only thing is I am just giving the different combination of different problems. Okay, so this is stage 1. So what about stage 2? I said stage 2, the line is inclined to VP and parallel to HP. Now since the line is inclined to VP and parallel to HP, true length will be seen in top view. I need to start from top view. Okay, what are the details in the top view? In the top view, I know that end Q is in VP. What do I end Q is in VP? If I say end Q is in VP means your locus of Q should be on X1. Let me consider, already we have a Q point here. So let me consider this is my reference point to draw the top view. Anyway, now it is given that inclination is with respect to phi is 60 degrees and of course its length is 75 mm. So then what I do then? Here I will draw this line which is inclined at 60 degrees and I will take the same TL. Okay, somewhere here I will get. So that if this is Q, then what about this end then? Other end. Which is the other end then? Other end is P. Let us call it as P2. Okay. So this is P2 and if I draw this, I will get the locus of P. And as usual, if I just project this, I will get the, anyway, this angle is phi. So I shall see this theta is 30 degrees, phi is 60 degrees and this length should be equal to your LFV. Now as usual, I know LFV, I know LTV, I know this row size. So I need to arrange this LFV. Now remember, if you have done the problem right, then what do you expect this LFV? Because anyway I know some of the inclinations are 90 degrees. Now if I take this arc, so where you expect this arc to cut? Whether it cuts somewhere here, it should cut here itself. It should cut here, or why it should cut here, or actually tangential, or it should not cut, simply speaking. It should be tangential to this locus because some of the inclinations are 90. So that is the only your hint. But anyway, because of your errors in drawing, sometimes you may get below also. So don't unnecessarily scratch your head. So we know that it should be there. So simply draw the arc up to that point. Is it okay? So I will take this length, then I will draw an arc. If you want, you can show this arc also, you can show. So which is that arc I am telling you? We are just getting this arc. This is the arc, LFV arc. So it should come here. So that this is my final Q dash. So this is what either you can do, or I can do here also. I can do. See, you can do any fair you can do, but I think we will do here itself. I think why unnecessarily getting confused. Let me not draw here. Okay, now LFV with P as center, LFV as a radius, draw an arc. So if I draw the arc, I should get here itself. So this is Q dash. Similarly, anyway I know that Q dash Q should be same projector. Where is your Q? Q is here. So where do you expect this Q to be then? On X. When I am here itself, I will get this Q. Then P dash is here, anyway locus of P is here, and also P dash is the same projector. So then what you do then? I will draw the projector like this. So that this becomes your final P. Now if you have done the problem, right, as I said, this should be same as this length, and this LTV should be same as this LTV. And remember, if you just see this particular case, since some of the inclinations are 90 degrees, the final projection should be perpendicular to XY line, and also the line is contained in side view. Now as I was saying you, this problem can also be done with the side view. So let me do that. So let me draw XY line. So since I want to do the XY line, I need to consider one of the profile planes. Which profile plane? Let me say I will consider profile plane onto my right. Now since I am considering onto my right side, which profile plane we are considering? The RPP. But whatever you project on RPP, since we are doing a first angle projection, which side you are going to get? I am going to get left side view. Okay. Okay, let me do this. So this is XY line. This is X1 Y1 line. This is O. Now I told you that since some of the inclinations are 90 degrees, the line is contained in profile plane. Since the line is contained in profile plane, I will see the true length as well as true inclinations directly there. Anyway, no, true length is how much? I know 75, and it is given that end P is in HP. Where is end P there? I told you that in the side view, remember, in the side view, this OY represents HP and OX1 represents VP. Remember, in the side view, we see both the planes. Since we see both the planes, even both the angles also has to be seen then. Because you know that if we consider the top view, so top view, what details we see? We see only VP details. If I say front view, what details we see in the front view? We see only HP details. But in the side view, we see both the details. Now anyway, I know this length is equal to 75, and also I know that one of the end is in HP. Okay, let me consider this is my NDA. I mean NP. NP is in HP. Okay, now I know true length of the line. I know. What is the true length of the line given? It is given as 75 mm. So I should draw the 75 mm line. So I should draw the 75 mm such that this angle should be equal to how much? 30 degrees. Now since this is 30, anyway these two lines are perpendicular, I will get this to be angle to be 60 degrees itself. Okay, and also remember, since I draw this particular line 75 mm line, I will get this 75 mm. Remember, after drawing this 75 mm, the other end should be here only. Q. But anyway, I am just doing randomly now. So since I am doing randomly, whenever you want to do this problem, first get this. You get this P1 and Q1. Anyway, this is side view now. That is P1 double dash and Q1 double dash. So get this line. Anyway, this angle should be equal to how much I said? This is theta. What is this angle I said? This angle is phi. Because anyway, there are complementary angles or their theta plus equal to 90 degrees. But anyway, since I am marking this point randomly after doing this problem, since it is 75 and this angle is 30 degrees, you may not get exactly on this line itself. Then what do you do then? First get this line, then draw the x1 y1 line. So that you have to keep it in your mind. Okay, but anyway, since I am doing just like that, I am considering here it for 75. Okay, but strictly speaking, when you are doing on the drawing sheet, you have to first get this 75 with this angle, and also since I know that P is in HP and Q is in VP, then I will draw this x1 y1 line, so that now I can say that P is in HP and Q is in VP. Okay, now I just draw the front, side view. Now I need to draw the corresponding top view as well as front view. Okay, now let us say first draw the front view. Okay, now we know that always remember front view and side view, they are in with each other in line. So obviously what I do then, I will draw a projector through this. And anyway, P1 dash is here, so P dash should be on XY line. Now I can draw this line anywhere. Why I can draw this anywhere? Because I have not mentioned how much this particular line is from RPP. Generally I will not give that. since I have not given the details of this particular line with reference to RPP, I can draw this front view at a convenient distance from this X1, Y1 line. Okay. So now since this is, what about this? This is Q1 double dash. This should be what then? Q dash, your final projection. Then what about this? Because anyway this is P1 double dash, this should be P dash, your final projection. And also remember, now I need to draw the corresponding top view. Okay, what is the procedure to draw the top view? Because if you want to draw the top view, what all I need to do is I need to get the VP distances. Where do you get the VP distances here? I am getting from this. Because anyway the side view OX1 corresponds to VP, and anyway we know that to transfer the VP distances, the best way is wherever we have the top view at that particular quadrant, I need to draw the 45 degrees line. So I will draw this 45 degrees line. Line. Now use the procedure. What is the procedure? So draw the projector. Here also draw the projector. Okay. Then anyway, this is the projector through P1 double dash. This is P1 double dash projector. This is P dash. So we know that P dash and P should be on the same projector. So I will simply draw this line. So that this will be your final point P in the top view. What about Q now? See, Q is in VP. So since Q is in VP, I will draw the projector. That is VP distance is 0. So I am going to get here itself. So this will be your point Q. So don't you feel this method is very simple? Because anyway this, if you want to do, I need to do 3 stages. This I can simply do it in a single stage. Because the line is contained in profile plane. Is it okay? Thank you.